Alright, second video in the Drake equation video series on Villagerdome. Haven't received any contentions regarding this basic premise that there's no positive evidence besides our existence, which doesn't mean anything in terms of assessing possibility or probability. Well, possibility, it does decisively answer the possibility question. It doesn't answer any part of the probability question. But we do have lots of evidence of improbability, the evidence that there is no other life forms on planet Earth itself, and all the other things that we've looked at in the universe say nothing. And other life forms would have billions of years of head start on us if they did exist, and one would expect them to be making enough noise for us to hear it by now. So anyway, lots of evidence saying life is a bizarre occurrence, not probable at all, not, just not. So anyway, Life in the Universe, Easy or Hard, Time Magazine, the scientist guy, Jeffrey Kluger, and very bad argument. So this is a Time Life video, and it's very bad.
Life is either very easy or very hard.
Well, we already know the very easy thing is impossible. That's just nonsense. So I think we've ruled out very easy. So now it's just how hard is it? Is it a one-time event in a millennium, in a forever, in a bazillionite? Or is it something that may possibly happen elsewhere?
Hi, I'm Jeffrey Kluger, and this is Time Science.
Well, let's get to it already.
The camp that says life is easy suggests that whatever happened on Earth is easily replicatable elsewhere in space, if only because there are so many other stars, and now that the Kepler Space Telescope is looking for planets, we know that there are many, many other planets out there as well.
Right. So the argument from if you do it enough times, the monkeys will type Shakespeare again. No. No. You can't, okay, well, I'm not going to, yes, I will. This probability stuff, you got to understand, one event demonstrates nothing. It has no value in assessing probability.
If it could happen here, there's no reason it couldn't happen there.
Yes, there is reasons. There's a whole bunch of reasons. We can't even dissect how bizarre and complex the process is that shoves this bit of chemistry together. More than one compound has to interact in a specific way to create a replicating cellular organism. It just isn't that simple.
Paul Davies, the cosmologist at Arizona State University and the author of the book The Eerie Silence, believes that life is statistically just unlikely outside of Earth.
Yeah, well, statistically is another tricky number, but yeah, we can. The information we do have is about the non-existent, so we can statistically understand that in billions of years of life evolving on Earth, with body parts strewn all over the place, no other form of life has arisen, no other structure. It's only one DNA molecule that we're all related to. And that says something. It screams a truth statistically.
Life is too complex, Earth-like planets are too rare, and no matter how many stars there are in the universe, when you crunch the numbers, we're probably alone.
Yeah, well, that probability thing, again, is just so hard to do. But, I mean, what we do know is it doesn't happen easy. So you could say, like, double diamonds can take place, like some sort of or emerald inside of a diamond. It might be a possibility, a theoretical possibility, but it would require some kind of bizarre circumstance where the emerald goes into the plasma of the diamond in its, non-crystalline, heated form, and it has to do it at just the right moment not to get disintegrated, and just so it has a millisecond time frame. It's like a meteor flying through this window when I open it. It's just bizarrely impossible kind of odds.
I think life is easy. I think with so many worlds...
Yeah, well, that's just a silly thing to say. It's easy is a silly word to use. We know, it's already proven fact that it's not easy. If it was easy, we could do it. We could make one. So it's silly to use the word easy. Just silly.
Out there, and the basic chemistry so readily available, there will be life on other worlds. It doesn't have to be intelligent life.
Yeah, it says you. Based on what evidence? That's right, absolutely no affirmative evidence. You have one time it happened on planet Earth, that's all the evidence you have, and yet you say it will.
It may not rise above the level of microbes, but from microbes we emerged.
Yeah, so what? Yeah, we emerged from raw elementary chemistry. Doesn't matter.
So at some point on some other planets there can be intelligent life as well.
It says you. Again, your premise is wrong. So, yeah, your premise that it's easy is wrong. So this idea that it will, twice now, the first will and the second will, that there's no obligation for any of it to happen, and you still haven't explained how it happened, so it's impossible for you to say it will.
Now this is more than just probability at work.
Yeah, okay, see, that's stupid. This is more than just probability at work. Here you go. So you're a physicist, you're a scientist. One assumes you're a science editor. And here you don't understand what probability is. Probability doesn't mean how many times do you roll the dice. It doesn't matter how many times you can roll dice if what you have to do is stack all the dice 6 high. Or if you have 6 dice and you have to get a 6 on each dice and they have to land on top of each other in a 6-high tower, it doesn't matter how many times you roll the dice. There's certain limitations that say that just can't happen in the container you're rolling the dice. Okay? It's just bizarre. And it's functionally, factually bizarre that we are here in the sense that there's no evidence that it happens. So again, permutations is interesting. But permutations, again, doesn't tell you what the structure has to be and just how bizarre that structure had to be. The dice had to, 3 of them had to be rolled once, and then the other 3 had to be rolled at another angle, and it's just, no matter how many times you roll the dice, you're never going to roll them that way again.
The complex hydrocarbons and the mix of organic chemicals that make us what we are in fact very common in the universe.
Well, again, it doesn't matter because they're not very common in the arrangement that makes them into a replicating organism that can evolve. I mean, these are key functions. I mean, even the idea of replicating doesn't mean much if it can't evolve beyond the first form that copies itself.
The reason life began in the oceans on Earth is because water is essential to life as we know it, and also because water, at least on a planet in the Goldilocks zone, not too hot, not too cold.
Yeah, well, again, so this premise of all life being based on water or something is also a misnomer. I mean, the idea of what a life form is the idea of you have a replicating entity, a thing, a device that replicates itself. And that it can do it through mutations, and so it can change the form of that replication. So it probably would require, for there to be fast evolution, there would require this idea of writing the code on a DNA molecule and having the DNA molecule evolve rather than the device itself. Have the copy be changed in the information for the future copy, rather than actually having to physically change the device in some kind of constructive way. The evolution can take place in the nucleus much quicker than it can take place in the real world.
Can be very warm and amniotic. That's a very nurturing environment for life to evolve.
Says you again. I mean, there's no evidence of that. It could have been a sea of ammonia that the first living thing grew in, rather than water, and that it learned through poisoning itself with its own poisons of water and hydrocarbons, that it learned to live with hydrocarbons.
We now know that the universe is fairly awash in water. We see water in interstellar space. We see it in interstellar clouds. It's perhaps Jupiter's big moons that have the most promise. We see water on the surface and beneath the surface of moons such as Europa and Ganymede and Callisto, all of which...
Well, this is all just so irrelevant. Again, I mean, this whole idea that the water is the essential property, I think, is another false premise.
Are thought to be able to keep water in a liquid state because of the gravitational pulsing that warms their interior. It's a little bit like when you bend a wire hanger back and forth and it becomes too hot to touch. Of course, it's also possible that there are extraterrestrials, and we're it. Plenty of people believe in the theory of panspermia, the idea that incoming...
Right, because they have nothing better to do with their time, so they just move God to some other planet. You know, so it's just another... Maybe it's double panspermia. Maybe the life on Mars got there because a meteor landed on it from some other galaxy. Why keep playing the game? We know that the chemistry itself has to be created. You have to create the replicating molecule somewhere.
Asteroids from deep space carry the organic compounds that first seeded the Earth.
Seeding, this whole seeding idea, I mean, the point isn't so much the seeds are everywhere. The point is how do you combine them to create something that will live, that will germinate into a replicating system.
And there are some people who even suggest that Earthlings are in fact Martians, who originated as single-celled organisms on Mars, rode to Earth aboard rocks blasted off of Mars, and then populated our planet.
And like I said, I don't know how it makes any difference whatsoever. Again, the argument is how rare is the process of abiogenesis, the conversion of raw chemistry into replicating chemistry, evolutionarily capable replicating chemistry.
There's more and more evidence that Mars was once a warm, wet, watery place, and some life that evolved then may still be living beneath the surface.
Yeah, so I mean, just make it up. Sure, maybe. Maybe in the depths of the moon, there's the surviving life form from an asteroid from Mars. So an asteroid from Mars hit the moon, and there's still a little donut sitting somewhere on moon. Does that mean there's life on moon?
If we go there and we find it, maybe we're just coming home.
Yeah, whatever. So now you got a nice little fairy tale story to tell, just to make yourselves seem all the more magnificent and all the more interesting. Yes, we're not really just Earthlings, we're Martians too. It's just a game. Good, play the silly game. Call it science. Okay, that's all there is. Bunch of NASA photos. Anyway, so yeah. So again, it's just not probability. That's what he said, right? So it has no understanding of, there is no such thing as probability in the first place. There's just inevitability, and all there are variables. And the argument being made here is the variables are huge in terms of the variables that can exist for the creation of a life form. There's the variables of the energy level, there's the variables of the existing chemistry, and you know, what form of energy, I mean, all the variables of the kinds of energy that can exist, from heat to electricity, all these different things are the variables that go into the forming, the conforming, the forcing of the development of a replicating machine. And so maybe something, like I said, quite bizarre has to take place. Lightning strikes at all the right moments, electricity at all the right moments to force something together, to close something, to seal something. We have no clue, and it's just all presumption. But what we do know is there's a ton of variables, not a tiny number of variables, but a huge number of variables. There's all kinds of ways these dice can be rolled, and there's very little chance that we can say, this roll, it only happened this one time this way, that because it happened this way, that it can happen some other way. Can't say that. And we can't say that this way is going to be a likely way again, because it could be something absolutely preposterous, like opening a window and having a meteor fly in.